Okay, welcome back, kiddos. Now we are moving on to a different part of trigonometry with the sine and cosine ratios. Okay, so remember last time we talked about tangent. Now we're going to talk about sine and cosine. So with last time's understanding, I think this one will go quite smoothly. So our essential question today is: how is a right triangle used to find the sine and cosine of an acute angle? And is there a unique right triangle that must be used? Okay, so we talked about any of these ratios. So these are called trig ratios, right? Any of these trig ratios are just the ratio of the lengths of two sides of the right triangle. Okay, so remember if we said, for instance, on this one, A. Okay, so let's go ahead and label the hypotenuse first. Okay, go ahead and label the opposite side. Okay, opposite from there would be this. Okay, the adjacent side has to be the other one. Okay, so last time we talked about tangent. Okay, tangents when we're working with the opposite and the adjacent leg. Okay, but sometimes we aren't given the opposite and adjacent. Sometimes we're just working with the adjacent and the hypotenuse. So instead of tangent, we're going to use the one called cosine. And then also, sometimes we don't have adjacent and hypotenuse to work with, or opposite and adjacent. We have the third combination, which is opposite and hypotenuse. So if we know or are working with those, then we're going to choose to use sine. Okay, so what we're going to do today is we're going to practice which one will we use, sine, cosine, or tangent, based off the information they give us. Okay, so we have an easy way to remember it as well. Okay, so if we remember that sine is opposite over hypotenuse, then we can just think SOH, S-O-H, right? One way to do it is like that. So, and then we can remember cosine is adjacent over hypotenuse. So we can think K. And then tangent we talked about was opposite over adjacent. So we can think TOA. Okay, so on your PSAT and SAT, when you're doing these, I want you to write down SOHCAHTOA. Then you'll remember sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over the adjacent. SOHCAHTOA. So if you remember that, then you can build this, and then you can do that. All right, so keeping that in mind, the main thing also is our calculator. It has to be put into degree mode. Okay, so what we want to see is in there in black, we want to see degree. Okay, so as long as it's set there, then we're in good shape. All right, so let's keep that in mind. Let's take a look at this first problem over here. Okay, so we talked about, we said, which one are we going to use? Sine, cosine, or tangent? So this one's asking for AC. This is asking for a different question. This is 1A. Okay, so AC. If we're trying to find AC, so let's go ahead and mark AC. That's what we're trying to find, right? We're going to label it with an X. So from the perspective of 35, right? That's the angle that we're working with. Let's go ahead and label the sides. Okay, so first off, I know this is the hypotenuse, right? This has to be the opposite side, and this has to be the adjacent then. Okay, so which two sides am I working with? I'm working with this, right? I'm trying to find the x, so I'm working with the opposite, and I'm working with this 15. So I'm working with the opposite and the hypotenuse. So I look over here, which one has O and the H? OA, AH, OH would be sine. So that means I'm going to use sine. So we'd say the sine of 35 degrees is equal to the ratio of opposite over hypotenuse. So we would say x over 15. Right? And then we would solve that like we did last time. Okay? So we'll come back to these problems afterwards. All right? So these are the next level problems. All right? So next, let's look at 2. Okay? So take a look at this. See what you think. Is it going to be sine, cosine, or tangent to find FD? All right, hopefully you tried it on yourself. So FD, let's go ahead and mark FD, and let's put an X there because that's what we're trying to find. Okay, next, this is our reference angle, right? It's 50. Let's go ahead and mark the hypotenuse first. So we said this is hypotenuse. Okay, then from here, the opposite side would be this, and then A. Okay, so what are we working with? We're working with x, so that's the adjacent side, and we're working with 30, so the hypotenuse. So AH. Okay, which one has A and H? AH is cosine. All right, so we're going to say the cosine is our answer. So we would say cosine of 50 is equal to the ratio of adjacent over hypotenuse, so x over 30. Okay, and then we would cross multiply. All right, so thinking about that, what would we use to find angle R? All right, so hopefully you try. This is a little tougher. Try to find angle R. That means we're trying to find the angle. So we're going to use inverse trig to find the angle, right? We want to find a side. We use trig. Okay, so we use inverse trig to find the angle. So let's try to figure this out. So for this angle, let's label the side. So I know this is the hypotenuse, right? So then from this angle, this is the opposite, and this has to be the adjacent, right? So what am I working with? I have a 12, so the opposite, and I know the adjacent. So opposite and adjacent means tangent, but I'm not going to use tangent. I'm going to use inverse tangent, right? So we would say angle X is equal to the inverse tangent of opposite over adjacent, so 12 over 5. Okay, so we would just type that into our calculator and that would give us the answer. All right, so actually, let's just skip this stuff right here. We're going to skip those. All right, so keep that in mind about which one we can use. So that's what today's lesson is about. Okay, we're going to either use tangent like we did last time, or sine or cosine, but the same procedures. All right, so keeping that in mind, what if I told you on 5, I want you to list the sine, cosine, and tangent. Okay, so think about the sine from perspective of P. All right, so from perspective of P, we know sine is, now what I'm going to do first though, I'm going to get rid of this, and I'm going to put it down here. Because on your paper, I don't think we had enough room. Okay, so I'm going to take that out. I'm just going to put it right over here. Okay? All right, so now let's just think about these. So sine first. Okay? Sine, we said, well, let's do this. So, toa. Okay, so we know sine is opposite over hypotenuse, right? So from angle P, opposite would be 35 over, let's go ahead and label that the hypotenuse. Either way, that's the hypotenuse, right? So 35 over 37. Okay, now the tangent is of P would be opposite over adjacent. So opposite would be, I'm sorry, sine, opposite, right? 35 over adjacent would be this one, 12, right? 35 over 12. So 35 over 12. Okay. Next, let's do the cosine. All right. So you got this one, cosine of P, right? Cosine is adjacent over hypotenuse. So from here, adjacent would be 12 over 37. Okay. So if you notice right here, we have the 3 different combinations of these sides. So when we know all 3 sides, we can actually use the sine, we could use the tangent, or the cosine. So can use any, because all 3 sides. Okay, since we know all 3 sides, we can use any of these to find out those angles. Okay, so think about the same thing from the perspective of n and answer these 3: sine, cosine, and tangent. All right, for sine, for n, right, sine is opposite over hypotenuse. So from here, we would say opposite is 12 over 37. Okay, tangent, from n, tangent is opposite over adjacent. So opposite would be 12, adjacent would be 35. Right? And then finally, cosine of n. Cosine of n. Okay, cosine we know is adjacent over hypotenuse. So adjacent would be this, 35, right? Because that's opposite. So adjacent 35 over 37. Okay, so that's our answers. Okay, so if we were not sure if they could reduce or not, we would type those into our calculator. So on our Desmos, they're asking us to see if those were reduced. So here's all we do. We would type that in, 35 over 37. Okay, and then we would get a decimal, so we'd push that again. Okay, it keeps the same, so let's just push the enter button. We would try the next one, 35 over 12, so we can even put 35 divided by 12. Okay, and then I can just push that again. Oh, that's supposed to be 12, right? 35 divided by 12 still reduces into 35 over 12. Okay, and then 12 over 37. So 12 divided by 37. Okay, so sometimes they will reduce, sometimes they won't. So if they wanted a decimal answer for this, actually, right, we could say it's approximately 0.324, right? So on any of these, we may have a fraction or it may have a decimal. We know that they are representing the same amount. Okay, so sometimes they'll ask us to reduce it. We want to see if it reduces. No, it does not reduce. It's still going to be 12 over 37. All right, so we're going to skip this. Well, actually, try this and let me know if you get this. Okay, tell me if you get this. All right, so let's go and move on to the next page. All right, so now we're getting right into some practice. That's all we got to remember is what are we going to do? So, ka, or toa, right? So let's write that down. So, ka, toa. Okay, so it says solve for x. All right, so let's take a look at this. If we're looking for x, the only angle we know is this, right? So let's go ahead and put that as a reference angle. Let's label our side. So first I know the hypotenuse. Okay, and then I know opposite of 60 would be this, and this is the adjacent. Okay, so if I know I'm trying to find a side length, I can use trig. Right? So let's look at what we're working with. We're working with the adjacent side and the hypotenuse. So adjacent and hypotenuse tells us cosine. Right? So because we're going to, let's put this here. Right? That's terrible. All right, so ka. Right? All right, so let's see. Cosine of the measurement, so cosine of 60 is equal to the ratio of adjacent over hypotenuse, so 80 over x. Right? Okay, so that's the hardest part, is just setting it up. Now, let's just cross multiply, right? So we know we're going to put that over 1. We're going to cross multiply. Okay, so remember, cosine 60 times x, we're going to put the x first. So we're going to say x cosine 60. X cosine 60, right? Make sure it says cosine 60 right there, x in front. Now, 80 times 1 we know is just 80. Okay? Now, we don't want this, we want just x, right? So remember, a common mistake is to just divide by 60, right? But if we did just the 60 on both sides, the cosine would still stay there, right? So we need to divide both sides by cosine 60, right? That way both get rid of. And then we have just the x. Okay, so x is approximately. Now, we're just going to type this into our calculator, right? So let's go and pull it up. Make sure we're on degree mode, right? So it should say degree, right? So let's just put cosine, 80 divided by cosine of 60. Okay, and it tells us it is 160. Okay, so one thing you may have noticed is that this is a 30, 60, 90 triangle, right? Because if that's 60, this has to be 30, right? And if we remember that, we had the short side, the hypotenuse is twice as long, and then the long side was x times the square root of 3, right? Well, if the short side was 80, right, we said the hypotenuse is 2 times it, right? So 2 times 80 is 160, right? 2 times 80 equals 160. So it's a different way of finding that same answer, right? So we could have used our special right triangles, or we could just use trig. All right, so keeping that in mind, let's keep it moving. So this one, you may notice, It comes from a DCP. So this is exactly what we should expect. These are multiple choice. So let's go ahead and just answer this and then see which answer is correct. Okay, so it says which expression can be used to find the length of QR. Okay, so QR. So let's go ahead and mark QR and let's go and put an X there for what we're trying to find. Okay, so which one of these can be used? Well, let's not think about this. Let's use our information. So we know that's our angle, right? So let's label our sides. So I know this is the hypotenuse. Okay, so if this is my reference angle, this has to be the opposite side and that has to be the adjacent side. Right? So which two sides am I working with? I'm working with opposite and adjacent. So which one's opposite and adjacent? Opposite and adjacent is tangent, right? We know it has to be tangent. So we would say the tangent of 20 is equal to the opposite over the adjacent, right? So x over 19. Okay, and that's not specifically our answer, but it might be either this or this, right? So we know obviously this one and this one cannot be correct. So it's either this or was this, right? First off, we know it says tangent 20, so we know this one cannot be correct, right? But let's just do the math to get it from right here, right? We're going to cross multiply, right? So if we put that over 1 times x gives us x equals 19 times the tangent of 20 is written as 19 in the front, then tangent 20 in the back. Okay, so that's how we came up with that. So that's how you'd get that answer on your DCP. All right, let's keep it moving. Here's another DCP question. Okay, so pause the video, see if you can get this one on your own. All right, hopefully you pause this one to push yourself. Km to the nearest tenth. Okay, so find Km. That's what they want us to do. So Km is this right here, right? So it's x. They want us to find a side length. So we say, cool, let's use trig. Okay, so let's label our sides. We know the first step is we're going to label that one hypotenuse. Now, if this is our reference angle, then let's label our opposite right over here, and then our adjacent sides there. So what are we working with? We have the opposite and the hypotenuse, right? Opposite and hypotenuse. Opposite and hypotenuse tells us sine, right? So we're going to remember sine is opposite over hypotenuse. So let's just say the sine of our angle measurement of 32 is equal to the ratio of opposite over hypotenuse. So x over 40. Okay? Now this is a little bit different from this other one, right? We're going to have to do the math, but we got this. Let's just put it over 1, right? 1 times x is just written as x equals sine 32 times 40 is written as 40 times the sine of 32, right? We got that, 40 times the sine of 32, right? Now, all we got to do is just use our trusted calculator. Let's type it in, right? Once we do the math, that's the hardest part. After that, we just type it in. Okay, so 21.19, they want to the nearest tenth, so it's like dimes, right? So 21.20, right? We'd say like x is equal to $21.20, right? So $21.20 would be this one right here. Okay, and of course, I know it's the tenth, but we know if it's a 0 on the end, we can just back it off. That's why it's this. All right. Nice. You would have got another one on the DCP. Let's check this one out. Ooh, this looks gross, right? But we got this. Let's check it out. It says Aaron wants to find the length of PN. PN. So I know this is not a great copy. So let's go ahead and let me have you fill in this stuff better. Okay, so first off, this measurement over here is supposed to be 34. Oh, actually, I think I drew it on your copy. So hopefully it's visible, right? So that's 56. Okay. This is X and this is 7. Okay, so they want us to find PN. So they want us to find this right here. Okay, so let's go ahead and label our sides. I'm just going to change colors real quick. Label our sides, right? So they're asking, well, first off, we know this is the hypotenuse, right? But we don't know which angle we're talking about. So it says, which of the following equations can she use to find this? Okay, well, let's go through these. It's asking which one of these. So just 1, 1 and 2, 1 and 3, or 1, 2 and 3. So let's see if this is true or false, right? So sine 34. So 34, right? So from the perspective of 34, let's see. The sine of 34 would be equal to, right? We know it'd be opposite over hypotenuse, right? So the opposite would be x. over 7. This says sine 34 is x over 7. Sine 34 x over 7. So yeah, that one would be good. All right. So next, it says cosine of 56. So let's look over here. If it was cosine 56, we know that's right? So that would be adjacent over hypotenuse. Okay, so let's do that. If I'm looking from 56, adjacent, this is the opposite, right? So adjacent would be x, and this is always our hypotenuse, so x over 7. So we said cosine 56 is x over 7, cosine 56 x over 7. Yeah, that's good too. All right, so what do we know? Well, we know that one can't be correct, right? We know A's wrong, but oh, this is 1 and 3 only. We know 2 can be correct, right? So we know that can't be right. So it's either this or this, right? So it really just depends on if 3 is correct. So let's check this out. Tangent of 56. Remember, tangent is opposite over adjacent, right? So let's look. Tangent of 56 equals the opposite. So 56, the opposite side is, we don't know that, right? So we don't know what that is. It's a question mark. And the hypotenuse is 7. So, I'm sorry, adjacent would be x. I'm sorry, right? Adjacent would be x, but we don't know what this is, right? So we can't say it's 7. That's wrong because 7 is the hypotenuse. So that is incorrect. So the correct answers are 1 and 2. So B is our correct answer. All right, so those are 4 questions, or 3 questions from the DCP. Maybe we'll get exactly the same or very similar. But I know that we can do this, so make sure that we got this down. So before our next class. So go ahead and do the practices now in Delta Math on this before we move on. All right, so now just like we did last time, we talked about trig to find the sides, right? Trig to find the side length, and then we said we're not going to use trig, but inverse trig to find the angle measure. Okay, so inverse trig ratios find angles. Okay, so for instance, on this one, right, if we're saying from the perspective of A, right, if this is our perspective, to find that out, right, if I wanted to find out this angle measure, angle of A, I would take the inverse sine, right, because I'm trying to find an angle of, we know sine is so, right, so I'd say it's the inverse sine of opposite, which would be B, let's go ahead and label those, sorry. Opposite and the adjacent, right, from A. So opposite, which would be BC, over the hypotenuse, which would be AB. Right? So go ahead and fill in these other ones for the tangent and the inverse tangent and the inverse cosine. Okay, so the inverse cosine, if I was trying to find this angle, but I only knew the right? We know that's going to be adjacent and hypotenuse. That would be AC over AB. AC over AB, right? Okay, and then the inverse tangent. Tangent we know is TOA, right? So that would be opposite over adjacent. So opposite over adjacent. So BC over AC. BC over AC. All right, so keeping that in mind, let's just get right into it. We're just going to think SOHCAHTOA. All right, so these, once again, are some DCP questions. All right, let's do it. Given this triangle, TPA, right? TP is 35, okay? PA is 20. What's the closest to, this says measurement of angle T, right? This is measurement of angle T, right? That's what that's saying. All right, so if we're going to find the measurement of angle, we're going to use inverse trig, right? Okay, so let's figure out what we're going to use. So if we're trying to find angle T, this is our reference angle. So let's label our sides, right? So this is going to be the hypotenuse. This is, from here, that's going to be the opposite, and that's going to be the adjacent. So what are we working with? We're working with the opposite side and adjacent, so we can use inverse tangent, right? So we're going to think TOA, right? So we're going to say the inverse tangent, right? That's the main thing because we're trying to find an angle. Inverse tangent of opposite over adjacent. So 20 over 35. Oh, 20 over 35, right? Uh, oh, I'm sorry. Like this, right? X, which is what we're trying to find, is equal to the inverse tangent of opposite, over adjacent. So 20 over 35. Okay, so now that we figured out what to do, just type it into our calculator. So remember, we're going to push that function button first. Oh, I'm sorry. What I like about this too, you can just push that back up to go back, right? That way I can keep it. Let's push the enter button. So inverse tangent of 20 over 35. And so now I'm going to push the main button again. 20 divided by 35. Okay, I can either put my parentheses or not. 29.74. 29.74 leads us to that. That's the closest one. All right, so we're just using our trig and figuring it out. Got another one. Boom. All right, now let's look at this one. This one's a tough one, but I'm going to show you a couple different ways. I'm going to show you the first way. I'm going to show you one way using trig. Okay, and I'm going to use the second way using 30, 60, 90 special right triangles. All right, so first off with trig. It says, which of the following expressions represents the length of AC? Okay, so AC is this right over here, right? So let's think about this. From this perspective, right, this is x, that's what I'm trying to find. This is my opposite, that's my hypotenuse, of course. So if that's the opposite, this has to be the adjacent, right? So what are we working with? We're working with the adjacent side and the hypotenuse, right? So what can we do with adjacent and hypotenuse? That would be c, right? So we're going to say the cosine. So the cosine of 30, right, is equal to the ratio of adjacent over hypotenuse. So we're going to say x over 12, right? Okay, so now let's just do the math, right? So if we put that over 1, right, x times 1 is still going to be x equals, and then 12 times the cosine of 30 is 12 cosine 30. Okay, so now let's type that into our calculator. Okay, so 12 cosine 30 gives us this, 10.39. Okay, so x is approximately 10.39. Okay, but we don't see any of those as our answer because these are in radical form, right? Right, and then this is our decimal form, right? Okay, so it depends on if they ask us to round it or not. Now, I'm going to show you in just a moment how we could figure out which one of these. Well, actually, yeah, I can figure out which one of these, but let me just do the math first, all right? So, because that's just a test-taking strategy. So we know this is our answer, right? But we don't know which one of these is the same, right? So let's take a look. A 30, 60, 90, though, if you remember 30, 60, 90, just like we just practiced earlier, right? If this is the 30, and that's the 90, this has to be 60, right? Because these two have to add up to 90, right? So that's my 60. Okay, and we know in a 30, 60, 90, the shortest side is across from the 30, right? So that's going to be x. The hypotenuse is, if we look at our notes, is twice as much as the short side, and then the long side is square root of 3 times. So if we take this, we multiply times the square root of 3, right? So let's check that out. We said we're going to go from we would go from the long side to the hypotenuse to the short, then from the short to there, because we would just divide by 2, right? And then multiply times the square root of 3, right? So let's say that, right? The short is equal to the long, which is 12, divided by 2. So 12 divided by 2, which is equal to 6, right? Okay, and then we said the long is equal to the short times the square root of 3, right? So that means the long is equal to the short, which is 6, times the square root of 3. Okay, so that's why our answer is this. Okay, but I'm going to show you how we can use our test taking strategy, right? We said that this was our answer, but this is what we came up with, right? But we also talked about this being this. One of these is the same answer, just written differently. So let's just type that in: 6 square roots of 3, and we see that that would be our answer is 10.39, just like we found. Okay, so it's a different way of finding the same answer, just with a test taking strategy. But if we didn't know the answers first to work with, then we'd have to use our radical. So that's the basics of it. I know you got this. Just let me know if you have any questions. All we're going to do is think SOHCAHTOA. Just write that at the top, SOHCAHTOA, and we can go from there.